Hello, and welcome back to the Stratford Public Schools Technology Department's Digital Learning Series, Tech Tuesday. Today, we are shifting gears. In our last session, we discussed the knowledge constructor, how students gather and synthesize information. Today, we dive into Standard 1.4, the innovative designer. This standard challenges students to use a deliberate design process to identify and solve problems by creating new, useful, or imaginative solutions. It asks us to move our students from being recipe followers, who just do what they are told, to being engineers of their own learning. During this session, we'll thoroughly explore the 4 indicators that define the innovative designer standard. We will dedicate significant time to live modeling with Dr. Eckler to ensure you walk away with immediate, actionable strategies for building critical thinkers in your classroom. The big idea here is the design process. Innovative designers don't just stumble upon answers. They iterate. They tolerate ambiguity. They know that failure is just data collection. Our goal today is to show you how to use our district technology tools to scaffold this complex thinking. The Connecticut Digital Learning Standard Innovative Designer is transformative. It states, students use a variety of technologies within a design process to identify and solve problems by creating new, useful, or imaginative solutions. This standard is the blueprint for active problem solving. It requires students to be empathetic observers, deliberate planners, and resilient iterators. Let's start with the foundation, the deliberate design process. Let's start with Indicator 1.4.a, the deliberate design process. Students need a roadmap. They cannot innovate if they don't know the steps. We need to provide a digital structure that forces them to slow down, empathize with a user, and define a problem before they ever start building a solution. Indicator 1.4a asks students to know and use a deliberate design process. The key word here is deliberate. Often, students treat projects like a checklist. Do step 1, then step 2, and never look back. But authentic design is cyclical. It's a messy loop where testing a prototype might send you right back to the drawing board. We need to teach them that moving backward in the cycle isn't failure, it's refinement. The process begins with the hardest step for students, stopping. They want to rush to the solution. But the empathize phase forces them to look outside themselves. Who is this for? What do they need? Once they have that data, they move to define. This is where they frame the problem. Instead of make a bridge, the problem becomes build a way for a squirrel to cross the road safely. The tighter the definition, the better the design. Now we ideate. This is the brainstorming phase, but it requires discipline. The first idea a student has is usually the same idea everyone else has. We want to push them to the third right answer, the one that comes after the obvious solutions are exhausted. In this phase, there are no bad ideas. We encourage wild creative risks before we start filtering them down to what is actually possible. Step 4 is prototyping. A common misconception is that a prototype is a finished product. It's not. It is a draft. It is a question in physical or digital form. We want students to think with their hands. Whether they are using cardboard in the makerspace or creating a Google Vids pitch to explain a concept, the goal is to get the idea out of their head and into the real world so it can be tested. Finally, we test. This brings us to Indicator 1.4.d, tolerance for ambiguity. This is where the learning happens. When a user says this doesn't work, the student hasn't failed. They've just collected data. This feedback loop is the engine of innovation. It sends them back to the ideate or prototype phase to make it better. This is the exact process Dr. Eckler is going to operationalize for us right now using Google Docs by showing you how to build a design thinking launchpad using a tool you use every day.
Hello, educators. I am Dr. Michelle Eckler, and now we're going to be talking about the biggest trap that happens with Standard 1.4. We've all seen it. The moment you say design challenge to students or problem solving to students, and they immediately grab for glue guns or opening their coding app or whatever it is you're doing, our students do suffer from the idea of solution bias. They want to build the robot before they've even identified who the robot is for. We need to treat the design process as an intentional skill, not just a suggestion. If we don't structure the thinking for our students, they will skip empathy altogether. So I'm going to use a Google Docs to create what I like to think of as a design thinking launchpad. It's not really a worksheet, but it's really more of a set of cognitive guardrails. I'm going to set up a system that literally forces them to pause, observe, and define the problem before they are allowed to build a single thing. Let's look at how you might set up a document like this. So let's take a look at this blank version first. First, we have here the phase tracker, or could also be considered the table of contents. Here, I've inserted a table and labeled the rows with the 5 areas of the design thinking process. And then my students have the ability to change their status depending upon where they are in the process. So we have here empathize, and here they're not started. That's where that one will automatically start. And then we have the different areas. Now you'll notice here that this one is considered locked because there are certain guardrails that students need to complete before they can move on to the next phase of the process. Now that we've taken a look at the way students can track their phases in the design thinking process, let's take a look at phase 1 of the process, and that's to empathize. And here we've provided students with an empathy map. So their goal is to understand the user's needs before they try to solve them. So whatever that problem is that they're looking for, they want to understand what that problem is. And so here they would fill in their target user, and then they would complete their empathy map. The empathy map asks them to look for exact quotes via an interview. What exactly is it that the user is saying? And then what is the user thinking but not saying? What actions or behaviors do you notice? And then what emotions is the user showing? These parts of the empathy map allow your students to get a better understanding of what it is that their user actually needs before they develop some sort of solution for them. Now, here is the key part of this design thinking launchpad. We have this gate check here. Our students cannot move on to the define phase in which they actually come up with what the problem is and what they're going to actually do to solve that problem until they have done these things. So they have to interview at least one real user, not just themselves. They have to record at least 3 direct quotes from the person. They have to identify a pain point based upon the data. The idea here is that students are actually taking the time to think about what their users are saying. Now let's take a look at what this would look like when a student actually uses it. So here's a partially complete design thinking launchpad for our student Jordan M, whose project is titled The Cluttered Desk. And so you'll see here that Empathize is in progress. They have not started defining yet, and still Ideate, prototype, and test are locked. So let's take a look at this empathy map here. So the student got some quotes directly from Sarah, who's a grade 5 student, and they have been able to get what the user is thinking, what is happening from the user, and how the user feels. You can see here that Sarah says that her water bottle keeps sweating and getting her papers wet, and that she also later on thinks that she wishes she had more space for her Chromebook. That's what the user is thinking. The user is putting their water bottle on the floor where it gets kicked, and then the user is getting frustrated when papers get ruined. Now, this is that kind of sweet spot here because the student is forced to record that quote before they come up with what they're designing. It's not just a desk organizer anymore. Now, in that case, they're actually designing a specific solution for water bottle condensation. So if we come down here to our gate check, this is our constraint checklist. The student has checked off that they interviewed one real user. They've recorded 3 quotes. That's actually untrue. This student actually only recorded 2, but this is a very well-crafted empathy map. So sometimes these numbers aren't what you want to focus on. You want to focus more on the quality of the empathy map. But they haven't identified a pain point yet. So this is a place where the student would have to stop and say, what exactly is the pain point? What is the problem that this person is encountering that I need to solve for them? And this visual kind of gate stops students from grabbing the cardboard and the tape or whatever it is that you're using for the prototype and turning it into an arts and craft problem, and instead turning it into an engineering problem. What is it I can do to help solve this person's problem?
Now that they have a process, they need a problem to solve. This brings us to Indicator 1.4.b. Real-world design is about working within constraints. It's about budget, time, materials, and audience. Often, students struggle to come up with solvable problems. Real-world design is never about doing whatever you want. It is about working within constraints. Real engineers have budgets. Architects have zoning laws. When we give students total freedom, they often freeze or choose the easiest path. But when we lock the door, when we say you have zero budget and only recycled materials, that is when their brains actually turn on. We need to stop fearing limits and start using them as catalysts. However, defining these constraints is exhausting for teachers. You can't invent 30 distinct engineering challenges before 8 a.m. And often, if you ask students to find a problem, they stare at a blank page. This is where AI becomes your superpower. Instead of asking students to pick a topic, we use AI to simulate a client with a specific, solvable need. Dr. Eckler is going to show us how to use MagicSchool AI to instantly generate these authentic, constrained challenges that get students building immediately.
So now, as part of the standard, we want our students to solve problems, right? But pick a problem is often too broad for our students. We need some parameters for them. So I'm going to actually use MagicSchool AI to generate some specific constraints for our cluttered desk scenario, and then we're going to put them back directly into our Design Launchpad document. So I'm going to go into MagicSchool and I'm going to look for my project-based learning tool here, and I'm going to actually do this as a 5th grade assignment. And I am going to say here that this is a grade 5 engineering problem and that I need a design challenge where students must build a desk organizer. It must solve the problem of limited space and spilling water bottles. And here I'm also going to give it some additional information. I need the design constraints to give my students. Let's fix my spelling because that will bother me. And we're going to go ahead and generate and see what it comes up with. And so here we've been given a lot of information here for our students. And here at the bottom is specifically what I'm looking for. Now, this is giving me a ton of design constraints for our students. So I'm just going to pick through and give a couple of them. So let's say I only have, I have a zero. Let's update this. Let's say I have a $0 budget. And let's see what it comes up with. And so it's going to now give me this whole challenge. Now you can go through all of this as a teacher and take a look at them. But for this particular section right here, since we already have our Design Launchpad, we are focusing specifically on the design constraints. So we're going to go with cost as one of them. So let's copy cost and we're going to go back. This is the form that we've given our students. So we're going to put a constraint as cost. I am going to go back and let's say I'm going to go with size limit because let's say I'm focusing a little bit on some math here. So we're going to do size limit. Didn't really paste the way I wanted it to, even with my Control Shift V. So I'm going to fix that up here. Just give it a quick little fix. There we go. So it can be no taller, no larger than 25 by 30 by 25 centimeters and no taller than 25 centimeters. Let's go back to my project and let's give it the bottle test here as well. So these are the design constraints I'm going to give my students. Fix that up too. Let's get rid of this part here because I don't think that's needed in there. So, okay. So now I have my design constraints in here for my students. This now tells your students they have to come up with the strategy, how they're going to make sure that within this design thinking process that they are meeting these constraints for their prototype that they're going to be working on next. Now, MagicSchool is a great tool for you as an educator to help you come up with that information. To come up with that on your own probably would have taken a lot longer. But now you can do this quickly using MagicSchool, and you have this launchpad where your students can keep all of their thinking. They have their empathy, their definition, and their planning all in one seamless engineering notebook, so to speak.
Before we let them build, we have to make them think. Usually, a student gets the constraints and immediately picks the first solution that comes to mind. We call this the safe idea. It works, but it isn't innovative. To push them towards Standard 1.4, we use the Safe Wild Hybrid framework in our Launchpad. We force them to write down a wild idea, one that ignores gravity or budget. Then we ask for a hybrid. This forces them to pull the creativity of the wild idea back into the reality of the constraints. This is where actual innovation happens. Let's look at a real example of why this framework matters. If we had just asked this student for an idea, they likely would have stopped at Idea 1, a simple cardboard box. It works, but it isn't innovative. But because we forced them to go wild in Idea 2, they started thinking about robotic dispensers and magnets. That idea is impossible given our constraints. No electronics allowed. However, look at the magic in Idea 3. The student took the mechanism of the robot, dispensing a pencil automatically, and engineered it using gravity and cardboard. They moved from a tray to a gravity tower. This is the hybrid sweet spot. This is how we push students past the obvious answer to the innovative solution required by Standard 1.4. Once the plan is in place, we move to 1.4.c, prototyping. This is the making phase. But we need to bust a myth here. A prototype is not the final product. It is a draft. It is a question in physical form. Whether it's a cardboard model or a digital sketch, the goal of a prototype is to test the idea quickly. We want students to fail cheap, to find the flaws in their logic before they spend weeks building the final version. In the digital age, we don't always need wood and glue to prototype. We can build powerful conceptual prototypes using multimedia. To do this, we are going to explore Google Vids. This tool is a powerhouse. It allows students to combine their innovative sketches, voiceovers, and screen recordings into a professional pitch. It features a built-in teleprompter that helps them articulate their design thinking clearly. Dr. Eckler is going to show you how to use the recording studio to build a pitch from scratch.
All right, now that we have our constraints and our plan, now we prototype. We're going to use Google Vids to create a video pitch, a digital prototype that proves that the concepts that our students came up with works. So we're going to start with a blank Google Vid, and the student is going to literally be their own director here. So the first thing we're going to do is click here on this record button. This is the recording studio, and a student can actually go in and add the content that they want to say out loud here. So this is a very powerful feature for our students because they can copy and paste their explanations that they already wrote directly here in this scene here. And now they can look at the camera when they're recording and actually explain their design confidently without having to stop and think. Now, they also don't need a film crew to be able to do anything here. They're going to click here on Insert, and they can actually insert photos that they've taken of their diagrams or their models or whatever they've done. They can upload video recordings that they've done with, say, a phone at home or something like that. They don't have to actually be a video editor here. They can just add things to this page. Now, this is the most important part. Once the students are done, we don't want this getting lost in their drive. So they're going to go ahead and share it. So let's give it a name. We're going to call it video pitch. And they're going to share it with their teacher. So whoever their teacher is, they would add that person's name. They're going to share that person as a viewer, and then they're going to copy this link. They can also send it directly to their teacher, but I'm not going to notify here. And then we go back to our Launchpad, and we're going to go ahead and add this here. And if we paste in the link and hit the tab button, it's going to replace it with this chip version here. And so now I can go ahead and do my self-check and determine whether or not I am all set with my prototype pitch to move on to the next phase.
Finally, we reach the hardest skill to teach. 1.4.D. Tolerance for ambiguity. Design rarely works the first time. Students need to learn that a failed test is actually a successful data point. We need to assess their iteration, not just their final product. To do this, we need a feedback loop that encourages refinement. In a traditional classroom, getting an answer wrong means a lower grade. In design thinking, getting it wrong is just part of the process. Design rarely works the first time. Students need to learn that a failed test is actually a successful data point. It tells them what doesn't work, which brings them one step closer to what does. To teach this resilience, we have to change how we grade. We need to assess their iteration, not just their final product. If we just put a grade on the final project, the learning stops. To do this effectively, we need a feedback loop that encourages refinement. A conversation, not a correction. Coaching and improvement. Dr. Eckler will now demonstrate how to use Google Docs to close that feedback loop.
Now that we've gotten to the last step, which is indicator 1.4D, tolerance for ambiguity, we're getting to the point where students have to actually analyze their failure, and it's up to us as teachers to coach them through it. Remember, failure means first attempt in learning. If you don't fail, you're not learning. So if I just put a grade on this document here, the learning stops. Students don't go any further. So I need to actually force them to read my feedback and act on it. And in this case, I'm going to use the comment and assign feature that's built into Google Docs. It's a super simple thing. You've probably left comments on documents many times, but you may not have left comments for students. So in this case, I'm looking at phase 5, and the student has filled out the failure analysis section. The student wrote that the base was too narrow and that the center of gravity was too high, so it was top heavy. So I'm going to highlight that specific sentence here, and I'm going to do the add comment section here. So I go to insert comment. You can also do Control Alt and M. And I'm going to go ahead and assign it to a student. So I'm just going to go with my, in this case, you would type in the name of the student, but I have this generic account I'm using here. I'm going to click assign to them. And then I'm actually going to add my comment down here. And so I have my comment, great analysis of the center of gravity. You've identified exactly why it failed. Go back to your constraints matrix in phase 2. Remember the 8 by 8 inch limit. You noted your base is only 4 inches. You have 4 more inches of budget to use. And I'm going to go ahead and assign this here. And if I haven't already shared this document, your student would have shared this with you. So I would go ahead and share this document. I'm going to do that here. But since this is something your student would have in Google Classroom, more than likely, it's already shared with you. And so this is really a game changer because now it's a task and a student can't resolve this comment until they actually go in and do it. And here I'm going to use this project status to tell them that a revision is required and that they need to see the comments. And so now the student sees this red dot indicating that there is something that needs to be changed. Yes, this will require some follow-up on the teacher's part, reminding students about feedback, but this is a great way to provide feedback to students on this, and to get them to be okay with the fact that something might not have worked the first time around and that they need to try again.
Thank you, Dr. Eckler. Seeing those tools in action highlights that innovation isn't about the tool itself, but how we use it to structure thinking. To build innovative designers, start with the process. Use the Google Docs Launchpad to force students to empathize before they solve. Generate constraints. Use MagicSchool AI to ensure the problems are authentic and challenging. Prototype digitally. Use Google Vids to create rapid video explanations or pitches. Feedback loops. Use Google Docs and comments to make the refinement process visible and collaborative. All the materials for this session are available for SPS educators right now. We've included the customizable Design Thinking Launchpad Google Docs template, as well as the completed example used in this session. SPS educators can check the Google Classroom for these tools. Thank you for joining us today and for your commitment to empowering your students. We look forward to seeing you at our next session.